down.
Hello, Mr. Teacher.
Hello, Mr. Eric. Hello, Mr. Ryan. Okay, so today, remember? Yeah,
With diagonal.
that's okay. Today we talk about the sorting linked list. Yeah, sorting a linked list. Do you still remember what's linked list? Yeah, I talk about that all the time.
Basically a list.
Sort a linked list.
Why are we talking about linked list?
Look, this is the linked list, yes?
Yeah. Why are we talking about linked list?
Because it's fine.
Why don't you talk about something else?
We'll talk about something else next time, okay? So look at the linked list. You're given this head, right? Yeah. Do you still remember that a few weeks ago we talked about merge sort?
Yeah.
Yeah, merge sort. Yeah, like we given a list.
To merge a linked list.
Look, this is a list. The difference between the linked list and the list is that in a linked list, you usually given the head, which you can only travel followed by head to the end, right? But for the list, it's because it's stored continuously in memory, so it's a piece of continuous memory, so you can have this random access. You can take, okay, I wanted a third element, then I can retrieve it. But if you want to retrieve the third element of the linked list, you need to on. It needs to take on time, right? Because it needs to follow from the beginning, right? But the principle to sort the linked list and to sort a list is quite similar. For sorting a list, we can do the merge sort. Remember the merge sort? So what do we do about the merge sort?
To merge a linked list.
We cut into half, yeah?
Yeah.
We cut into half and then we sort these two and then we merge it together, right? So here it's the same. So how do we cut into half?
Why are we learning how to merge a link?
How do we cut into half? Do you remember we talked about finding the middle?
Yeah.
The fact we
Fast and slow and try that one.
Yeah.
Cut it in half.
So we know the middle, yeah? So we can cut it into half.
Yeah.
And then we can sort these two linked lists. Yeah, once the two linked lists is sorted, then what happened? We can merge it. Yeah?
Yeah.
Remember how we also talk about how to merge two sorted lists, right?
Yeah.
Like a list and another list. So we have a point. If these both are sorted, we have pointers, and then we compare the elements of these two pointers,
Yeah.
and then we move forward each time, right? Remember? Yes.
Yeah.
So the complexity.
Is there one?
No.
I won. And login. I won. Is there one? Is there
No,
one?
of course not.
And login.
Yeah, O1 login. Don't make a guess. O1 is very rare. I mean, do you get it? O1 means constant. Means that your complexity, your writing time does not change if your linked list is grow as much as possible, right? So for this one, we cut into half, and then we merge it, right? Yeah.
Yeah.
Cut into half is On, right?
Yeah. Why are we talking about?
And then divide and conquer, and then sort it. So we actually divide, and then we divide it every time divide into half is log n. So all together is On log n. Okay? Yes?
Yeah.
Okay. So I'm not going to write the detail for the finding there's only one difference is finding the middle, yeah? Previously you want to find the middle, right? You have two pointers, yes? One walk twice as fast as the other one, right? Like that. Okay, then here, and then here, yeah? But when this is slow, it's the middle. So now we actually need to disconnect it, right? Do you understand? We actually need to disconnect it. So what we will do is we return slow.next. We return this node. But we also set node.next equals none. So we disconnect it. So it becomes two linked lists. Yes?
Yeah.
Now once we have the two linked lists, then we can sort it until and then we merge it. Okay, so what I will do is here, define sort the linked list, yeah, which given the head. Okay, so now look, so what we do, if head is none or head is none. Return what? If it's
None?
yeah, return head because if it's head, it's not nothing or it's a single node. We just return itself. Okay? Then we have a node. Now we need to get the middle of the one, right? So now what we do? We got a mid equals let's say get mid. Okay? Let's have a function get mid head. But this function does not simply return the middle of it. It also disconnect it, right?
Mm-hmm.
Yeah, we need to make sure of that. And then we have a mid, we have head. Now what we do? We said mid equals sort mid. Right? So we're calling this recursively, sorting the mid, the link, another linked list, the half of linked list. And then we also call the first head. Okay, let's call it head. It's head equals sort head. Okay? So now the head and mid are two sorted lists, right?
Mm-hmm.
Then what we do? Return merge what?
Return head.
Merge what?
Sort.
What? There are two
Middle.
Mid and what?
Sort.
What's sort? Sort is a function. Come on. I have two sorted linked lists.
Head.
Head, yes, because then I need to sort it, yeah? I need to merge it.
Mid.
Yeah, am I right? Yes?
Yeah.
Yes, does that make sense? Does that make sense? Yes? Does it make sense?
Yeah.
Yes, look, it makes sense, okay?
Dobby next.
Okay, so now, any question before we move on to coding?
No.
No?
Turn this off.
Wait, I do it, please, I do it.
How do you turn the thingy off?
I turn it off. Can you, okay, this is a bit. Is it on? Is it on?
Yeah, need me all the way. Ow.
Yeah.
No signal.
No signal. Why is it no signal? Ah. Is there no signal? Yeah, okay, come on. Yes, I need to see. Yeah. Good? Okay. Good? Yeah, that's good. Wait.
Really? Is it now?
Why is the keyboard is still showing? Ah, yeah, perfect. Okay, perfect. That's fine. So is it clear, yeah? Is it clear? What? Why this keyboard is still showing? Just give me a second to get rid of the keyboard thing, please. Okay. Okay, so now let me turn off this thing so it's good. Okay. So now what?
It's still showing. Let me get rid of it.
Wait. No, I think there's a problem. Let me do it.
See Mario, even like a Mario.
Yeah, that's better. Let's do it better. Yeah. Okay. Yeah, that's good. That's good. So now we can still use this print list, and then remember the last time we talked about the case head to the last. Yeah. Do you still remember?
Yeah.
We don't need this. Let me just remove this. Okay. So now we have a node from 1 to 10. Okay. 1 to 10. But let's do a run. Let's first of all let's first of all create a node from the scratch. Okay, so let's see data equals just give us some random number. Okay, and then let's define the
Lots of threes.
data. Okay, so now if we print the list, so what we can have if we print a list head message is just something. Okay, let's see. So number 9 I have
It doesn't look like any problems.
number 9 return new node is complaining this one. Why you complain this one? I will not change it. What does it say? Inconsistent use of tabs and inconsistent use of tab. Number 9. So I will mess around. I did mess around with the tab. So I need to. So now this is tab. I use the tab instead of space. What? Tabs and space indentation. Number 9 return node. What is it? Why it does not like it? Return new node. Should be alright. What? I don't get it. Just why it doesn't like it? That's so weird. Is there anything I return new node, return that's 2 space, 2 tab.
It's not really.
What? I don't get it. Why it doesn't like it?
I think this is what it means.
Why
is this all together?
Look, when you print it, yeah, it's all together, yeah. So look, there's something wrong with this one.
Why is like Rita?
Okay, yeah, Rita. And another thing is this. I hope this is okay. Add node. It's the other one. I don't get it. I think there's some issues with the formatting, but let's try. Let's try just to type it again and remove all of it. And then we can remove 10 to 15 lines. What? What? The first one is the
Why did not all turn to white? Yeah.
Yeah, it's very strange. Why is that? It's kind of very strange. Defined. Save. Next now equal now.
None there. What's none there?
Okay, save the word var, save the next node equals next node, and then 5 to 8, I remove it. Wait, I spotted some errors. There's an extra space here. This time should be alright, right? Aha, okay, so now it's better. For cat, okay, it's very strange, you know, because this is not a very user-friendly editor. So you don't see any visual space. Okay, so now this is random, yeah? It's not sorted, right? The linked list is not sorted, you see? Yeah? Now let's do the coding. So in order to do this, we can do this. Look, this is before sorted, yeah? Before sorted. Now we need to, first of all, after sorted. Okay, let's change this to after sorted. After sorted. And then it's a YY command. Okay, let's see. Let's do it first, which is the called. Actually, we can write it here. Look, define this int ethno, and then we can also say we can define it here. Define what? Actually, let's write it outside, okay, which is clear, much more clear. Okay, we don't want to mess with the class. Let's see. Define merge A and B to linked list. Do you still remember how do we do this? We do a dummy head.
Dummy.
Which is what? Node.
Dummy.
Okay, and then P equals dummy. Y, A, and B. You can tell me what to do with this one. If A dot value is smaller than B dot value, so what to do? We need to use the value A, right? Yeah? P not x A equals A dot next node. Okay? Am I right?
Yeah.
You still remember how to merge it? And else P dot next node will be the B, right? B will be equals next node, am I right? And then P equals P dot next node. Move to the next. And then if A is still let we can read next node will be A. If B, P dot next node equals B. And then return what? Dummy dot next, right?
Dummy. Why
Okay, this is to dummy because we are not using it. Yeah? Do you get it? We're not using it. We're just using dummy dot next now. Okay, let's try the mid. Okay? Get mid, yeah? Head. We want to get the middle of node. Tell me how to do it. Fast. So wait. If head is none or head dot next is none. Yeah? If it's just a single node or nothing, we just return head, okay? Fast slow equals head, right? Y fast and fast dot next node. Then fast equals what? Dot next node. Dot next node. And then slow dot next node. That's it. Because slow node will only work one step at a time. And then return slow, right?
Yeah.
But before that, we need to let's call it break mid, because we're going to break it into break at the middle part, yeah? So we need to recall the previous node before the slow node. So we call it pre equals none, yeah? And then before we change it to slow equals node dot next node, we do this. Previous equals slow, right? Yeah? So previous is the slow's previous node, and then previous node dot next, what? Will be next node will be, let's break it, yeah? None, right? Then we return slow, am I right? Okay, then now how to, we have a break and we have a merge, and then let's sort it. Sort? Head? If head is none or head dot next node is none. Return head. We're done.
Mid equals get mid head.
Mid equals break mid. Break mid, then we break mid, yeah? Now we have this. Then head will become sort head. Wait. We need to sort this pit as well, right? Yes? Alright? Yeah. And then we can return merge.
Mid head.
We're done.
We're just calling it.
So the complexity is that. Then we can do this with when
look,
sort
and look.
head equals sort head, right?
Yeah.
And then I think here. Okay, let's see if it works. Okay. Oh, look, it's sorted. Yeah, you see, it's sorted. Got it? Yeah. Is it sorted?
But before sorted, after sorted.
Does it make sense?
Yeah.
So we actually just need you already learn how to merge two sorted lists. Yeah, this is
What?
you previously know how to do it, right?
I want to learn tomorrow.
And okay, and then you also know how to get the middle, right? The only new thing here is we have a list previous pointer. So previous is always one node before the node, right?
Is there something else to merge a linked list?
Look, line 53. Look, line 53. Previous node dot next node equals none. What does it do here, Eric?
Previous dot next node equals none.
Yeah, what does it do here?
Oh,
So you find the middle of the linked list. What does it do? The slow is the middle of linked list. The previous node is the slowest previous node. So previous dot next node equals none. What does it do here?
I don't get what you mean.
So line 53, what does it mean?
Previous dot next node equals none.
Yeah, what are we trying to do here? What's the function name called? Line 44.
944.
Yeah. What does it do?
Define break mid-head.
The line 44 to 54, what does it do actually, Ryan, Eric? Any of you?
It's getting
The middle node?
in the middle.
And what? And do one thing. Previously, I told you about the algorithm to get the middle node, which is without the line 48 and line 51 and line 53. Now I added this line 48, line 51, and line 53. What does it do here? We have a middle node and we have a node before the middle node. And now we are setting the previous node of the middle node dot next node equals none. So basically we are what? We are breaking it, right?
Yeah.
We are breaking this in the middle part, right? So you will turn into two nodes, two linked lists, am I right?
Yeah.
Okay, so do you understand point 953?
Yeah.
Yeah, and then now when we break the node, look, when we break the node here, break the node, then we can sort it, right? Let's another list sort it. And then we saw the first half, this is 960. We saw the second half, which is 959. And then we merge two sorted lists, which you already know how to do that. Is in here, line 27 to line 42, okay? Got it?
Yeah.
Any questions?
No.
Are you sure you understand? Because every time I ask you, you seem not understanding. Are you sure?
Yeah.
If you have any question, you need to tell me, okay? I probably will come up with an exam, yeah, for you to answer, okay? Do you get it? Okay, you can do a bit more dancing today. Say bye-bye to people.
Bye. Bye. Bye.
Okay, that's it.